Good day everyone, my name is Joshua and today I'll be presenting to you my final year project based on mitigating Hijacking session hijacking. The researchers are myself, Mr. Leonard Hartsing, Mr. Malcolm Williams, Ms. Emmanuel Yaqui, and Mr. Spear. An outline of what we'll be going through today. We'll first discuss the research problem, the fundamentals of session hijacking. We'll talk about Kochore, which is an application that we built to mitigate HTTP session hijacking, and a bit about future work that we'd like to see done in this area. So, session hijacking is one of the most popular attacks that hackers use to steal access to person's accounts on the internet. The main aim of our project is to find a way to stop this attack. The problem statement. Now, in an ideal world, you should be able, or internet users in general, should be able to use the internet without someone else gaining access to the information that they're passing over this internet. So, if a hacker tries to gain access to the information, he should be blocked. However, in our current situation, when the user is browsing the internet, a hacker can simply use attacks and gain access to this information. We will use this little box here as information, and you can simply download it in the system. Session hijack. So when you connect to a server, say you log into Yahoo. When you log in, a session is created here on Yahoo server view with your information, like your username and your password, etc. And the way Yahoo knows that your computer is connecting back to them, the next request that you send, say you're requesting your email or something, is a session identifier is passed between your computer and the server. So session hijacking is the exploitation of a valid computer session, where the attacker would try to steal the session identifier to gain access to Yahoo in this case as you. For instance, at the risk of session hijacking, since there are currently no method that fully prevents session hijacking, everyone who's using the internet is at the risk of session hijacking. A successful session hijacking attack can be detrimental, since an attacker can gain access to your company accounts, to your banking information, and we all know what they can do with that, right? So, just to show you how session hijacking works, say for example here we have John, or internet user, and he's browsing the internet. Sends information, so say he's logged into Yahoo. He sends information to the Yahoo server, he sends the session identifier. The server now checks whether the session identifier is the same, whether it's John's session identifier, and if it is, sends back John's information to him. An attacker at this point would basically steal the connection and download packets being transferred between John and the server. And since the session identifier is transferred, at every request, he can simply steal it. That's it. Now the next thing he does, while John is still browsing this server, he connects now to the server and tells the server that his session identifier is the same as John was. So now the website would check his session identifier is the same and will return John's information. And it's as simple as that. So, proof of session hijacking. How do we know that this attack actually exists and websites are vulnerable to it? Well, about a year ago, there was this tool called Hijacking that was released that allowed even intermediate computer users to hijack others' accounts. And we also conducted some experiments of our own. We managed to hack Yahoo and Facebook sessions. Here is just a demonstration.
For my network with the permission of it. So now I'm doing a simple session hijacking attack. This is done for my network with the permission of everyone using the network. So let's go. As you can see in here, this person is not logged into Facebook. So basically what you do is you use a tool to scan packets being transferred over the network. In my case, I'm using Wireshark. And I've been scanning packets for the last, say, 5 minutes. You notice these are the packets here. The next thing you do is you stop the scan. So after it's scanned a sufficient amount of packets, you look for the key packet with a cookie. And after some research, I found out that the two cookies that Facebook uses to authenticate its users is the user cookie and the access cookie. So we can just copy that, paste it there. So these are the two that we're going to need: CUs and access. And in the Firefox here, you use a tool like Cookie Manager to just inject these cookies. I'm going to add a cookie. Copy value or CU here. And next I'm going to add the access. Again, copy the value. Paste there, save. And then the next thing you do is just simply refresh the page. And there you can see here successfully session hijack this guy's account with his permission, of course.
So as you can see here, I basically stole his session identifier and got into his account without knowing his username or password. So, okay, why are we trying to build something new? Why not just use the current methods that are out there to prevent this attack? Well, first of all, no current method completely prevents this attack. The most secure of them, or most notable, is secure connections achieved through the use of SSL. However, secure connections are difficult to set up. The load of using secure connections is heavy on the server. It is very expensive, right? Therefore, it is not widely used. You don't really find much websites using secure connections. And even when secure connections are implemented, it does not necessarily protect against session hijacking. Our hypothesis: the introduction of other authentication methods, Kochore in our case, together with the session identifier, will minimize or remove the risk of successful session hijacking attacks. So, when you connect to a website again, though the session identifier is passed at the high level where the attacker can sniff it, other information such as the IP address and the user agent string is passed at the lower level where attackers, it's almost impossible for hackers to sniff this information. So the user agent string is a string that is almost unique to every user, and the IP address is an example address used to identify users. So our solution is to use a combination of the session identifier, the user agent string, and the IP address to authenticate this user when he connects to the server. Now, why did we choose this solution? First of all, it works by detecting potential attack, so the hacker does not gain access to the account. It uses data that is already passed between server and client, therefore it will be fast and lightweight, and it's a server application, so it won't be needed to, this application won't be needed to be installed on every user's computer. Demonstration of how our application work. So remember earlier that the hacker stole John's session identifier, right? Now, when John is browsing the internet, the attacker will try connecting. So when he connects, he will send the session identifier to the web server. However, the web server will not only check his session identifier, but also his IP address and use agent string to match them. And if it's not the same, the server would block John and delete the session identifier and request data, and then we generate a new session identifier for John. The server would block the hacker, and then generate a new session identifier for John. So the hacker would have to start the process all over again. The implementation of our solution worked. Yes, it did. Here is a demonstration with two websites. The first one using a normal server, and the second one is a server with our application itself.
It's a demonstration to show that our module works. What we have here is our two websites. The first one, testsite.com, and the second one, testmodule.com. Testsite.com, where the module is without the module installed, testmodule.com with our module installed. So what we're going to use is a simulation of a real world environment where, say, the user using a Google Chrome browser is a normal user, and the Firefox user is the hacker. So on a normal website, when the user logs in, you will see that he's logged in here, and if the hacker steals his session identifier and injects it into his own site, into his one cookie, he automatically gets access to that website as the user. But in this case now, if the hacker, say the user logged in, and the hacker steals the user session identifier, even steals the user session identifier, he injects it into his own browser. But even with doing that, he doesn't get access to this site. This is so because our module does not only check the session identifier, but also checks if the user agent string is safe and the IP address is safe.
So as you can see here, the module works. So now we wanted to know whether it was feasible to be used in a distribution environment. So we used some of the extracting tools to test the performance of this module, of the server with this module installed against the server without the module installed. And the results we found was that this module is about a server with this module installed is about 0.2% slower than the server without the module installed, which is not much performance overhead compared to the other solution that we use, Secure Socket Layer, which costs about 20% overhead by the server. Future work we'd like to see done in this area. Our module is currently built for the Apache web server. We would like to build this module for other web servers out there also. These are my references. That brings me to the end of my presentation.